Well, it's been a busy week at Uptime. We have a packed show, and Rosemary's back.
We're happy to have her as well. So we're going to speak about Avangrid raising some red flags in their U.S. offshore development plans with pricing and PPAs, and also kind of slide into what that means for the U.S. shipbuilders and what they're thinking about being a little bit hesitant to start building some of these vessels. And then also along the same lines of the U.S. offshore push is Staten Island area is getting some funding to build out a good port facility to get these New York facilities up and running.
And China is building the first offshore solar and wind combined facility. And then I have a great interview with 3S Lift America's president, Jill Chardon, and we talk about all things lifts. So stay tuned. It's a great episode. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with Australian blade whiz Rosemary Barnes and my good friend from Wind Power Lab, Joel Saxum. And this is the Uptime Wind Energy Podcast. Well, Rosemary's back after a long break, and welcome, Rosemary, to the show again. Thank you for being here. We had a really nice break, I take it?
We missed you.
Yeah, very relaxing. Yeah. I've got a 3.5-week-old little boy now, so yeah, he's been taking up my time, but he's with his dad now, so... Hope we can get through a podcast without any crying babies.
We have a new policy. We're calling it the Rosemary policy. And Rosemary, you can't leave anymore because since you left, the Queen died. UK has had two prime ministers, and inflation is rampant. The world's practically on fire at this point. It all seems to correlate about the time you took off. So welcome back. Maybe the world will come back in order.
I think some of those things happened before I went away, and others I'm not 100% sure that I'm directly responsible.
And we got no diesel fuel left in the United States either.
And no diesel fuel? That's exact. Yeah.
We're out. Oh, really?
Yeah.
Pretty much out of everything in the States right now.
More electric cars then.
It is a great time to have Rosemary back because we have a lot to talk about. The world is on fire, and that affects wind turbines around the world. So we're going to have a really good show. All right, top of the order, Avangrid raises a huge red flag in U.S. offshore, and Avangrid has been talking with the Massachusetts Department of Public Utilities, and in my wonderful state, all the rates are sort of set, electricity rates are set with the Department of Public Utilities. Avangrid, they're working on the Commonwealth Wind project, which is a 1.2 gigawatt project, offshore wind project. It's big. And they had negotiated PPAs with the state back in May, but now they're rethinking it. And they've actually filed a motion to put talks on hold for a month while they kind of regroup because they think the project is no longer viable. And Rosemary, they had agreed to PPAs of roughly $72 a megawatt hour. But it looks like they're going to be searching for some more PPA money. And obviously the major issues are, like we were talking about, commodity pricing, rising interest rates, supply chain delays, inflation seems to be out of control at the minute. What do we do? Like, where does it go from here, Rosemary? Do these things tamp down after a while? Is it just part of the process that the companies installing the wind turbines are going to be in conflict with the states that are sort of regulating the electricity prices?
Yeah, I wonder how many more are going to come after this, because there's two sides to it, that costs have definitely increased, and probably, maybe it's fair enough that they've increased faster than anyone was expecting a year or two ago. But I also think that, there's been such a bidding frenzy for these offshore locations, and we've all been surprised at how much people have been prepared to, or, developers have been prepared to pay for the rights to these areas. It seems like maybe they didn't include enough of a buffer for, surprises in the future. But on the other hand, energy prices are so high at the moment that I would probably expect that people would renegotiate and pay a bit more, because it'll probably still be a good deal. So I think that there's kind of, two sides that are kind of, I don't know, balancing out, and we'll probably see these agreements renegotiated to be a little bit of a higher price. And I don't know, maybe developers will be more prudent going forward to how much value they think that they're going to get out of these offshore locations. But I guess it's hard when you've got so many people interested, then you end up with a bidding war and you're going to have high prices because of that.
I wonder how long this PPA is for. I've been trying to find some numbers online, and I read some stuff 20 years and whatever, but I don't think that was applied to this one. I think that was more of the Vineyard Wind things, and there's a couple other contracts in there. But I think I would have, if you're looking at the shorthand in the last year, how much commodity prices, like you said, Rosemary, have changed dramatically. I would have a hard time signing a 10, 15, 20-year PPA right now. Basically, if you're looking at inflation numbers and the cost of labor and whatnot, like that's going to, if we continue down the path we are in the next few years, it's going to change drastically. And you may not, like they said, it might not be viable anymore. So maybe they need to shorten up the PPA or have hey, we can renegotiate after 3 years or something like that in there, besides having a set price for so long.
I guess the construction cost is, all the commodity prices are going to come in the upfront costs, and then the PPA is their long-term investment. I would have thought a longer PPA would suit them better at this stage, especially because energy prices are so high right now. But, if you're thinking 20 years in the future, it's hard to imagine that the average price over that time is going to be anything like what it is now. I hope that commodity prices are going to settle down. So I think that if I was a developer, I'd probably be keen to lock in a really, really long PPA now, if it could remotely resemble the price of electricity and other energy has been recently.
If it could help your financing, but I know like right now in the US, the finance rate's like 7%. It's the first time it's been that high in like 18 years or something, right? Since 2004, I think I read last. So when that's that high, I mean, the cost of, if you bought a $300,000 or $400,000 house, it's going to increase your payment by $1,000. So if you're going to be spending millions and millions and millions of any kind of financing rates that you have on that are going to be astronomical. So that's a part of it. Of course, commodities right now, like you said, Rosemary, steel, all the manufacturers saying they want to increase the price of turbines, anything, cable. I bet you the subsea cable prices have just gone crazy. I don't know what they are, but I'm sure they've gone nuts because of all the precious metals and stuff inside them.
Yeah, I bet you're right.
Is this perfect timing by Avangrid? Because the election is coming up, we're about, I don't know, a week away right now when we're recording from the election. By the time this pops out, the election will have happened. But it seems like the perfect time if you're going to put a project on hold, and as much push that the federal government's been pushing towards offshore wind, it seems like this is the perfect time to renegotiate, because the other side is not desperate, but almost desperate to complete this and to show that a project's moving. So can you just basically ask for anything right now? I think you probably can. You may get it.
Yeah. With that being said, they should have done this about 2 months ago, just so they had that window of like, hey, let's get this signed before the election cycle. We'll see.
That's true.
It's going to be
that's very true. And the government change in Massachusetts, it will change enough where it'll be to the advantage, I think, to Avangrid afterwards. That will be a really interesting thing to watch, because this is not the only project that's sort of floating around right now. Not sure it's going to happen. There's one off the coast of Connecticut, same thing. And as we were talking about before the show, the shipbuilders are also very nervous about building wind turbine installation vessels to put the ships in the water, because they're not sure these projects are going to happen. And the other variable is there's a need to maybe make the turbines larger. Instead of doing 15 megawatt, you may want to do 20. Maybe you want to do 25. You just need to wait a year. And so the turbine sizes may grow dramatically. And then if you built the ship today, it may not be useful for very long. So the whole supply chain is up in chaos because there's no bottom yet.
I think the shipbuilders are going to feel the same pinch, right? Because now with capital at such an expensive rate, and you're talking, building a $20 million vessel, if you're not 100% sure that it's going to go to work the day it gets put in the water, you might be a little bit apprehensive to stick $20 million in capital into a thing, So I know there's only what we were looking at. Dominion Energy is the only one, and they've got a 470 plus foot vessel is the only firm order in the U.S. And we need up to 6 more to reach that 30 gigawatts by 2030 goal. So it just doesn't look like it's happening. Nothing's moving.
Right, running out of time.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
So down at Staten Island, and Rosemary, I don't know if you've ever been to Staten Island. It's just near New York City, close to New York City. They're going to build. They're going to build a terminal down there to stage for offshore wind, so they can do some construction and assembly work right there next to the water. And they received a $48 million federal grant to move that project forward. And the reason they're doing it in Staten Island versus like Albany, and then there's a project going on in Albany, or supposed to be happening in Albany, is Staten Island doesn't have any bridges. So all the other potential port sites would have to go through a bridge to, and they're talking about Albany, to go through under a bridge to get to the greater ocean to move wind turbines out there. So the Staten Island Arthur Kill terminal will take care of that problem. It's a start, right? It's supposed to open or start digging the ground, in 2023. The developer's in the process of really finalizing all the approvals for the project, and 2023 is when I guess they're going to start, and then 2025 they hope to have it finished. As we were just talking about, the sequencing of events is really important here, right? So even if this project gets kicked off, which is probably the right thing to do, is it soon enough to handle everything that comes afterwards? Because if we do kick this open by 2025, then we're 26, 27, 28, 29, we're kind of, it's a short time frame to put a lot of wind turbines in the water. Do we need another one of these terminals? Do we need to put one in New Jersey to do the same thing to speed up the process? Is one
How many
enough?
How many sites will be continuously building out of there? There was 5 leases in the New York Bight, right?
Yes.
5 or 6.
Yes.
So
right.
if those 5 or 6,
got a bunch, yeah.
So there's going to be more than one consecutively. To be honest with you, in my mind, I would think that you're going to need a port per wind farm while it's actively building.
You think so? Oh boy.
I think so.
Yeah, we're not there yet.
Ooh. No. And someone, maybe our UK or Danish offshore installation friends can correct us or add something in here if we can get a comment on that. But knowing how fast they can move these things now, I know when they're in the blade and hub installation process, it's boom, ship in, ship out, ship in, ship out. They're quick. And I think they're going to be most of the construction here will be pounding monopiles. They're pretty quick as well, because it'll be the ship out there pounding them, and then the other ones are just delivering monopiles in sections. So it's a 38 or a 32. This is for a 32 acre facility. A 32 acre facility is nothing, really, in the grand scheme of things. If you think 40 acres is 1,320 by 1,320 feet, if one of these vessels is 500 feet long, or 472 feet long, the Dominion Energy one, that takes up the whole port. That's it. That you get one vessel in there, right? So by simple math, you're not going to have more than, you might have one work vessel and one jackup or one barge be able to use it at the same time. So maybe 2 smaller ships, but when the big ones come in and out, when they're loading blades, you're not going to have the blades themselves are going to be 300 feet plus long. So there's not space there for more than one vessel at a time.
Well, Rosemary, you've been involved in blades a little bit in your lifetime. I had looked at Vestas a little bit. I was looking at Vestas is going to be building wind turbine blades over in Italy for their V236 15 megawatt machines. So they're going to have 2 plants, one in Denmark and one in Italy, to make the wind turbine blades. And then a lot of those blades are going to end up with Equinor off the coast of New York. So they got to ship those blades a long ways to get to the States. I assume that's what's going to happen. Does that make sense? And are there vessels to haul that big of wind turbine blades across the ocean? Is that a thing?
Yes, so that is definitely a long way for those blades to travel all the way across the Atlantic, right? That's the that's the ocean between Europe and the US and New York.
It is today. Yeah.
So I assume that they're kind of testing the waters to see if this huge predicted US offshore boom happens, and that's why that they're planning to build them in Europe, because, you know, offshore wind is already booming in Europe. So building factories there is not such a huge risk. But I mean, we don't have a lot, or you don't have a lot in the US yet. And whilst there's a huge pipeline, you know, we already saw that, you know, some of these early developers are already having to renegotiate the terms and say they're not profitable. So I think it's fair to hedge your bets a little bit, you know, bid for projects in the US, but not commit to building a brand new, you know, offshore wind turbine facility, manufacturing facility over there yet. But my expectation would be that once, you know, that pipeline starts to firm up and people are pretty confident about being able to use their factory 24/7 for years in the future, that you'll get some factories being built in the US, because it doesn't make sense to ship everything all the way across the Atlantic for, you know, 30 gigawatts of wind turbines, offshore wind turbines.
Well, I know the GE Haliade X platform. Haliade. Sorry, Alan. They're building the blades up in Gaspé, right? So so those blades won't have to run as far. But we do know right now that there's only 2 wind farms that GE gets to put that platform in as of today.
Yeah.
So they hopefully they can resolve some of those issues that they've having on the legal side, and more of those platforms will get built. But you know, I have a good friend at Martin Bencher over in Denmark, and we've used them in the past to, you know, hey, can you give us a bid on this? We got to get a blade we have to get 1 blade to the Dominican Republic, or 1 blade to Uruguay, like those kind of things. So he gives us some insights on those. But that's something like Martin Bencher specifically they move LM blades, and they do a very good job at it. So they've got vessels and bunks and stuff specifically made for those. And, you know, a specialty company like that will probably get a bite of these contracts to move them across. But I wonder what the difference in logistics cost is coming from Esberg versus coming from, if Vestas made them somewhere in the U.S. in South Carolina or something. I don't know.
Right. Yeah.
What the cost
Don't you wonder that? I didn't realize there was an Uber for blades, but it makes sense that there is. And
But yeah, you mentioned that the Gaspé factory is making the Haliade X blades for North America. That's cool, because that was the first wind turbine factory that I ever went to. I did my training there back in the day, and it's probably my favorite factory. I'd say I loved it there. It's such a nice area, but it's a very small town. It'll be interesting to see how they can, you know, scale that up. They obviously must have, you know, physically expanded the factory there, because you could not have fit 108 meter long blade in the factory that I did my training in. But even for personnel, you know, it's small town, it would be hard to see how you could, you know, all of a sudden get a lot more workers if you needed them. So it'd be interesting to see how that goes. But I'm really glad to hear that they're still going strong, because that's a beautiful part of the world.
I would say with a little bit of knowledge about Quebec, if the workers and installation techs that are going to be on those Vineyard Wind projects were smart right now, they take some French classes, because the Quebecians will definitely write in French on those blades. They're going to have to learn it. You can't even order Tim Hortons there if you speak English.
Oh, really? I would struggle. I might just die right on the street.
Maybe it's just because they smelled the American on me and they didn't want to deal with me. But French is not my.
Who could really blame them? Really?
Yeah, right.
So how does that? Let me ask the question: how does this work on the Jones Act bit? So the Vestas blades are made in Italy. They put on a ship, I assume, of some carrier from somewhere, not America. They float to America. Can they just hand those blades over to the wind turbine installation vehicle in the water, or will they have to dock up, drop them somewhere, and then let an American vessel take them back out? What's the rule there?
I think they could swap them out at sea, but I don't believe that any QHSE professionals would like that too much. So I think they'll come in, they'll drop them at port. I mean, you could swap them out there, right? You could go at 201, outside of the exclusive economic zone, drop them and never come to port. And that's the way around the Jones. That's how you get around the Jones Act, right?
That's
I know
what I'm
people that have
wondering.
done.
Right.
I know people that have worked in the Gulf of Mexico and have gone to the edge of the EEZ to do oil changes in ships and then have come back.
Wow. Okay.
Because it saves them so much money.
There may be a lot of logistics involved with getting these blades in the cells, because I think the Vestas nacelles we made in Poland, so they're coming the same way. Yeah,
if you want to do that, the swap at sea, you can do it and get away with it. But I hope that doesn't happen, to be honest with you. I know everybody's trying to find ways around the Jones Act because it is, pretty intrusive, but I hope that stuff doesn't happen. I'm hoping that they come to shore, drop them off, the proper QA/QC gets done on the blades, on land once they arrive, and then they get loaded out. Boom, boom, boom.
Do they have to be QC'd on the ground before they fly them? Is that part of the regular process? Or do you say, I can inspect them on the ship, up they go, and we're moving on? They never touch land?
You could, but okay. I don't think, I mean, Rosemary, we do this a lot at Wind Power Lab, but I think Rosemary probably has a better view of the offshore plan. But I know we recommend, when they come off the line, have a third-party inspection before they get shipped. And we also recommend have a third-party inspection before they get flown to cover basically CYA all the way through the process to ensure that when you're putting the blades up, you don't have issues. But Rosemary, maybe you know more about that from a production standpoint.
Well, certainly for onshore, that's the way it's happening. I mean, you definitely don't want to discover transport damage when it's already up on the turbine. That's that's like a nightmare scenario, I think. And all of the issues that I get called out to for transport damage, their blades are always still on the ground. So I believe that that's what everybody's doing, and that's only going to be more relevant, more important for offshore than onshore. So yeah, definitely.
Because offshore you have a lot of, where onshore you may have like a double handling. You might have factory, then they move them out to the yard, then it gets put on a truck. That truck goes to site, drops it off. So you're handling it basically 3 times. But now if you're doing this offshore stuff, you're building it, you're handling it, you're putting it on the vessel, which is a handle, you're shipping it, you're taking it off the vessel, which is a handle, then you're putting it back on another vessel, which is another handle, moving them around, and you're like, all of a sudden you're touching them 6 times. And that's not ideal.
No, and I mean, transport damage is pretty common. I mean, it's one of the more common sources of large problems with blades, I think. I don't think you necessarily need to check the blades every time it, changes transport mode, but definitely every time that the responsibility for it changes, So if it's, the manufacturer that is, in charge of logistics up until the port in the US, then you wouldn't need to necessarily check it until then, because it doesn't really matter how the damage occurred. From the developer's point of view, it just it doesn't matter which leg it got damaged on. It just only matters that the manufacturer needs to fix it at that point. Right. And you don't want to find out after you've taken responsibility for it, because then you're going to have a nice big fight with your with the manufacturer about who's responsible for it. And I love those kinds of fights, because that's the exact sort of thing where I get involved to help out developers, but it's not easy to resolve, and no one ends up fully happy in those situations. So I would suggest.
You know what? Not at Hamburg, but the year before at Electric City in Copenhagen, excuse me, I had a conversation with a company that was doing some logistics tracking. They had a nice little, unit, one of these kind of things, right? And it had in it a cell modem, a GPS, some other things, and they were using it to track. They had, you could track vehicles, track a vessel. You could track a expensive toolbox. You could track whatever you want. And we actually talked to them about putting like 4 or 5 of these down the blade, and they had a little IMU in it, a little inertial measurement unit to sense G-forces and things. And we talked to them because the customer had the idea, thought of like, can we track these blades somehow? So then you would have, in the bending moments and stuff, you'd have a sensor on these things that would give you basically, if there's a heavy impact G-force, shock load, anything like that, you would know it throughout the entire transportation process. And also you could pull up on your little dashboard and know where your blades are at all times as well. So that's nice. We had the conversations a few times, so it's an idea. We never came to fruition with it, but just a thought.
Well, they do it. I've seen people on Twitter tracking their Tesla delivery in that same way. So, you know, obviously that's a thing that's happening. I guess that, you know, it's not an individual buying an individual wind turbine that is, you know, going to be tracking the exact location of it on its journey. That's probably the reason why we don't see it now, because, you know, what difference does it make to the developer, you know, exactly where it is in the ocean. But yeah, no, I think getting information about conditions during travel is definitely something that happens in all sorts of products do that. So why not?
Yeah, it's a great idea. I think it makes a lot of sense.
The idea came from a developer where they had, exactly like you say, Rosemary, one of these big battles where they got the blade and then the OEM was like, nah, man, all good. Manufacturing company, all good on our end. Trucking company said we didn't do anything. But they were thinking, they actually pinpointed it to, it was like a mile section of road where they were doing construction on it, that they took the wide load, like the truck through. It was in the US. And they went through a bunch of, like, they thought they could have went through a bunch of like potholes and stuff, and the blade was doing this. And they're like, why can we use this sensor to track those forces and that inertial measurement through those things, so we might be able to pinpoint a moment when this happened and be able to point a finger. That's basically what it is. Who has to cover cost, or whose insurance company has to cover cost? How about that?
Good idea. With all the continuous monitoring systems that are out on the market today, one of them should be able to do it, you'd think, today. Mm-hmm.
Yeah, you can get really cheap. Like I was using vibration sensors on some products that I was developing, you know, just to, I was using them so I could measure what types of vibrations I needed to test at, the frequency and amplitude and stuff. And the sensors that I was using, they were basically made for that purpose, not for wind turbine blades, but for other products to put in the in the packaging, the product packaging, and see, you know, what sorts of shocks has it been subject to in the transport. So they exist. They're very cheap. I think that the main thing probably stopping people doing it is just now you've got this bunch of extra data that somebody has to be employed to deal with, or more likely, you know, from the projects that I've said, it's very easy to get data and a lot harder to find the time to actually manage it. So you just end up collecting data and doing nothing with it. And then when you find, oh, there's a problem, let's go look at the data, you're like, oh, we'd never turn that on because you never use it, or, you know,
right.
It's a bit easier said than done, but I think if it is a big problem, then people will use this technology because it already exists. The solution already exists.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
So Norway, you don't think of solar when you think of Norway, but Norway's Ocean Sun has licensed their floating solar technology to the Chinese state-owned group State Power Investment Corporation, SPIC. So SPIC has built the first commercial offshore floating solar plant that is also integrated with an offshore wind turbine. So what it looks like, there's two circular pads of solar cells that are floating in the water, and there's a wind turbine sort of in the middle of it. It's a pilot project, and it's believed that if everything works the way it should, they're going to try to create a 20 megawatt facility in 2023. So we've seen a lot of talk about floating wind and floating solar being joined together, but the first place it's being done is China. So is this something that we can piggyback on? When I say we, California, piggyback on, because they're going to have the first floating wind in the United States. Do they want to piggyback some solar on it? Does that make any sense to do that?
Yeah, I remain a little bit skeptical about floating solar, but I can see that there is a trend towards it. There's plenty of developers interested in it, so it's probably has more value than what immediately jumps out at me. Yeah, I mean, you can save on infrastructure. You don't have to build separate subsea cables just for the floating solar. So, I mean, all of these kind of less appealing offshore energy sources or energy storage, they're always, based on the idea, we can just, piggyback off all the infrastructure for the wind, because, the wind in most cases is already profitable on its own merits. And then these other, technologies, whether it's floating solar or there's, a huge number of ocean energy storage companies in development at the moment. I just did a video on that actually, and it's the same thing where it's like, okay, yeah, it's complicated, but the offshore wind's already there, so we might as well just stick it on. And wave energy often, makes that argument as well. So yeah, there's a synergy there, but I don't know to what extent adding solar to an offshore wind farm is really going to smooth the output. I mean, you have a little bit less variability, but it's not like wind is only at night. Solar is obviously only in the daytime, but you are going to have times where you're going to have both of them running at maximum capacity. And then are you curtailing one or the other, or are you building the system that's big enough for, both of them at their maximum capacity? Or are you putting, your ocean energy storage in there as well to, smooth it out more? I think it's a little bit complicated. I'll be surprised if these are really commercially attractive in the next few years. I know that the articles say that it's, got the potential to dramatically decrease levelized cost of energy. And I think that that's just hyperbole, the kind that investors, or people say to attract investors. So yeah, there's some potential, but it's not straightforward and simple to me. It's not a slam dunk that this is going to make cheaper energy. I think it will start off being more expensive, but at least, we can iron out some of the kinks in floating solar. They say this is the first commercial floating solar, but, it's 500 kilowatts. So, you can call that commercial if you want, but it's not a lot compared to a wind farm, obviously. So we'll see how they go.
I think it looks like an O&M nightmare, to be honest. Like maybe if your wind farm's close enough to shore, and if one of these things goes down or has issues, you just tow it back. I don't know. That maybe that makes O&M sense, but otherwise, if they're big enough or it's a large enough commercial scale to have to be maintained in the field, I don't know about that.
Yeah, it's interesting to get a good look at it. It's like a saucer with a little lip around it. And I mean, I guess that their big problem, normally solar is so low maintenance. If you're in a dusty area, then you'll probably go and, hose them off once a year. And if you live somewhere with snow, then you got to clear the snow off occasionally. But when you're offshore, then obviously the salt water is going to be, like spilling in there and then evaporating. And so you're going to get, a salty film. So I'm imagining that there's going to be like what are those vacuum robots called?
A Roomba.
A Roomba? It's going to be like a Roomba with a squeegee. Yeah. A Roomba with a squeegee. That's going to be
or just a big windshield wiper.
Yeah, maybe something like that.
Yeah.
But hopefully it can be done without personnel going out there every week to wash it down.
To do it. So what do you think about if someone wanted to put, like, say, green hydrogen behind the meter, load wise? That might be a way to make make more sense.
Hang on.
Yeah, there's so many options. You have to watch my my recent video. Everyone should go watch it on ocean energy storage. We didn't actually talk too much about having an electrolyzer plus some sort of place to store hydrogen. That would be one way to do it with a pretty low round trip efficiency, though. Then there's companies in various stages of development, most of them, quite low maturity, doing like gravity energy storage offshore. There's a lot of different pumped hydro versions. So they're using the hydrostatic pressure from the water at depth to make a pressure difference. And then there's buoyancy storage as well, which is kind of like gravity storage in reverse. But there's a couple of companies say they're working on it, but it's like sketches on a website kind of level. Yeah, but for both the gravity storage and the pumped hydro, you get some advantage going offshore because you can have like a huge depth instead of, onshore. If you wanted to build something like the Energy Vault Jenga tower, like 50 or 100 meters is a huge, huge distance to go up with a structure above ground. But you've got floating wind, then you're going to have it in depths, could be up to, a kilometre deep. So you get, a much, much bigger potential energy change between the ocean floor and the surface. And the same with pumped hydro, the pressure difference. You can get a good offshore site somewhere where you might be far away from a good onshore site where you need, a big hill to make pumped hydro work cost effectively. So yeah, there's a lot of options. None of them are mature yet. And if they're in an offshore wind farm that's going to be putting power onshore, I struggle to see why you wouldn't just put a battery onshore where the offtake is, That to me seems like the far, far, far easier way to do it. And to me, I see the main reason why you would bother with some complicated offshore energy storage is going to be either if you're powering an offshore facility, like oil and gas platform, so the electricity never needs to go onshore, or if you need some long duration storage somewhere where there's not really good opportunity for pumped hydro, whether because the land is flat or because people don't want to look at it. Maybe it's easy to put a lot of duration under the water because people, there's no one's backyard. So, well, no human's backyard anyway, and the fish won't complain about it. That's the two places I see where it might happen.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
Next up is Gio Chaldon, president of 3S Lift Americas, where we talk how to keep your technicians on the job site longer and with less stress by using lifts. Gio Chaldon, welcome to the Uptime Wind Energy Podcast.
Thank you, Alan. Happy to be here with you.
Gio is the president of 3S Lift America, and this is going to be a great discussion because we just got back from Wind Energy Hamburg, where every operator and owner was talking about technicians, retaining technicians, keeping them on the job longer, and technician productivity. There were so many different kinds of systems that were trying to improve technicians' response time, technicians' ability to repair or make quick fixes to turbines. And I thought of 3S Lift when I was over there, and you were there represented at that show, but lifts are really going to be a big discussion point in the United States because there was a limited number of technicians. Making them more productive is going to be where the action is. So 3S Lift makes this climb auto system, and that's what I want to talk about today is this climb auto system. And Joe, could you describe what the climb auto system is, the sort of the fundamentals of it?
Yeah, absolutely. It's a single technician ladder mounted lift that allows technicians to get up and down the tower without climbing. So essentially it's kind of a climb assist like device with a platform and a couple of handles. The one's behind me in our training center here in Dallas, Texas. And it's a system that can be put on turbines during the construction phase, aftermarket, a lot of retrofits, repowers. So it's a real simple system that's a traction motor driven lift that goes up and down the ladder on a rail track. And really we've only been here for 4.5 years or so in the US. And the product now is reaching some maturity, and it's really exciting. I think it's pretty interesting to think, your comment on Europe focusing on anything efficiency, specifically related to technicians. In Europe, they have lifts in nearly every turbine, and they're still focused. To me, that shows, okay, well, they already have lifts, yet they're still focused on how to improve retention, efficiency, technician gain, so that tells us something. I think we're a little behind here in the States.
Yeah, we do a lot of things manually in the States, and that is very clear from seeing some of the systems offered in Europe. So what is the difference between a climb auto system and what we would typically call a lift? What separates those two?
We sometimes call the climb auto system a lift. It lifts you from the bottom of the tower to the top of the tower, but traditionally a service lift in a wind turbine is an enclosed structure. That most of them here are traction unit driven. They're cable driven from the top of the tower down. Some are mounted to a ladder as well, but the main difference is service lifts are enclosed, 1, 2, sometimes 3 persons, and our climb auto system is an open cart that you stand on and are fixed to the rail fall arrest system and go up the tower that way.
So once you have a service lift where it is an enclosure, those systems actually fall under different regulations in the United States, right?
Typically, there are some different regulations. Some states, not all states. There are certain states that have more strict regulations that require annual licensing, recertification of the service lifts. All of these systems in a wind tower, including a climb assist, they require some form of annual inspection, maintenance. Our system, the climb auto system, is self-maintained by our owner, the owner operators. Our customers maintain them themselves. It's quite a simple system that way, and that's one of the benefits of the climb auto system versus maybe a service lift, which our company sells, and we sell predominantly into Europe and Asian markets. But one of the benefits is the maintenance of our climb auto system is very simple. We see owners and operators incorporating that into their annual cycles.
And we saw your system in action down in San Antonio at the American Clean Power 2022 in Texas. It's really interesting because it is a retrofit system. It takes your existing ladder system and just clamps onto it. So there really is not a lot to do there. What are some of the pieces that you have to add onto the existing ladder to make the climb auto system function?
Yeah, that's a good question. The system can be installed in one day. We have technicians. Right now we've got somewhere around 20 or 30 teams of 2 technicians installing these lifts around the U.S. currently. And after some training, they can install it in an 8-hour day. Very basically, you take out the existing fall arrest cable. You replace that with our center rail, which is your new fall arrest system. You can climb the tower manually that way anyway. And that's it. We put a pulley on the bottom, a pulley on the top, a traction motor, and the car glides into the rail. So it's not there's no modifications that are done to the ladder, to the tower itself. Our power system is our control system is plugged directly into the down tower control system in the turbine. So yeah, it's a fairly straightforward process. Even in construction, when there's no backfeed power, we use a generator to power the lift and install it. And when the backfeed's available, your lift's available.
That makes a lot of sense. So from a operator or technician standpoint, there's a climb auto system in there. What are you doing? You're standing on it. I guess you're grabbing on to a couple handles. I'm assuming you're latching into the safety system. Is that all it's needed to get on it?
Yeah, really. You step up onto the foot pedals. You insert your fall arrest runner into the rail. There's 2 handles upon which you have to press the handle switches simultaneously. There's a dial switch on the panel to go up or down, and that's it. We spend about a half an hour per technician training each technician to perform the basic operations, the pre-use inspection, the startup stuff, and we certify each technician that way before they use the lift. And then finally we teach them how to perform an evacuation. Up or down, the foot pedals fold up, they're able to climb down and around the lift. If for whatever reason the tower lost power and they needed to come down, they can get around the lift pretty easily. So we train each tech in that process as well.
And the system can also take tools and gear and equipment up and down. It can act like a standard equipment lift.
Yeah. If having been I started in the industry as a technician, and it's one of the worst things when you forget a tool, or, oh, I should have brought that card up, or I left my lunch in the truck. Those are things that you have to call somebody and kind of have them come out to the tower, maybe send down a lift bag. In the past, that's what was done. Now, a lot of our customers are using the lift. There's a basket that latches onto the foot pedals, and they can send up 130 pounds of tools, equipment, remotely. So each technician will have their own remote control to operate the lift in that remote mode, which is handy.
So it's really a huge time saver.
We've seen a few key examples of how, and we're still measuring it, Alan. It's only been a few years. Right now, we've got we're nearing 4,000 units installed. By the end of this year, we'll have 5,000 units installed. So put that into perspective with how many towers are in the installed sort of post 1.5 megawatt era. There's still a lot left. But some of the savings we see are, the 3 p.m. climb, when your technician, your day is over at 3:30 and you're down tower at 2:30, and the turbine next to you faults. And maybe it's as simple as going up to the top box and swapping out a vibration sensor or something simple that you could do in a half an hour. You may not do that because you're avoiding the climb. So those are some of that's one efficiency gain. We also see some proactive measures happening. So a traditional annual inspection day, and let's say you and I are on a team and we're performing annual inspections, we're going to be in that tower all day. What we're seeing customers do now is when they come down tower, they go to the next tower and they just take a ride up the Climb Auto system, 5 minutes up, 5 minutes down. They spend 5 minutes, 10 minutes in the nacelle, just a visual inspection. Is there oil up here, or what does it look like? Because that prepares you for the next day. So they're gaining some efficiencies that way into the following day, which I find really interesting. We see an improvement in morale. I guess I'll say morale because we've got a customer that's had these lifts it's a 99 turbine site in Kansas. They've had lifts for 2 years. And the site manager told me prior to the lift being installed, they'd get to the office at 7. They'd mosey around. They wouldn't leave the office until 8:30 after they decide what they're going to do, get their tools, head to the tower by 9. Maybe they're not up tower until 9:30 or 10. Now, he coined it sort of, they're no longer afraid of the climb, right? They're not trying to avoid the climb, and they're at the tower at 8 a.m. So how does that flow down from an efficiency perspective if you're an owner and now my technicians are getting to the hour or maybe spending another hour in the tower each day? That's beneficial, so that adds up pretty quickly.
Yeah, that results in longer running turbines, more produced power. All those things start to climb because the technicians are busy enough, right? And if they're spending a lot of time going up and down, it just takes away from being productive. It makes sense, right? It makes sense why the Europeans have done that because, the cost of energy and everything's more expensive in Europe typically compared to the United States. And the American States tends to be more manual until we figure it out a little bit. And then we start automating things. And this Climb Auto system does make a lot of sense in terms of just technicians. And as we're seeing the age of technicians sort of creep up a little bit because it's so hard to get people into this technician world, it would make sense that we're losing technicians who have all the experience. Does the Climb Auto system help keep them around for a couple more years in those productive technician years?
We think it does. We really think it does. I've gathered some data from a large global OEM that has shared the following information with us. It basically says, if you have a site with a lift, whether that's a traditional service lift or a Climb Auto system, your retention is improved significantly. So their data basically says the average tenure on their sites that they looked at, a significant number, was somewhere in the 6 or 7 year mark for sites with lifts. Now, sites without lifts, where you're manually climbing or using a climb assist, was about 3 years. So you're doubling the retention factor. Now, we don't have enough data to see that yet here, but what we do know, and we did there's 2 surveys. I'm glad you brought this up, because there was a survey that the CanWIA group did a couple of years ago, which really showed the demographic pool is really small. 99% male, significant, the average, I think only sort of, 3 of 4 technicians are under the age of 35. 3 of 4 technicians have less than 7 years. So you have, and part of that in the U.S. is because our industry is younger than Europe potentially, but we certainly see that the number one reason from this CanWIA survey, the number one reason that technicians are leaving is because it's a strenuous job. And their number one claim for why it's so strenuous was climbing. So climbing is the hardest thing. And that's the main reason that we have technicians that are either getting into the industry and leaving, then let's eliminate it. And there are various products out there, including our Climb Auto system, that can do that. And there's certainly byproducts on the efficiency side that you can gain. But number one is, we've got a huge industry, and let's employ these people to have a career rather than just a job for a couple of years. So we certainly see that as one of the big reasons our customers are interested in this product is recruitment and retention. For sure is improving. I've spoken to a lot of technicians over the last few years that are younger than me that have had multiple, knee surgeries, and I forget, when I started at GE, in 2008 era, and my first time out in a wind farm, we liked to climb. We were excited about it. It was something macho about it. And after about a month or two, it's not that cool, And I remember one of the techs saying that, being in wind, you start at the top and work your way down, and from a field perspective, right? But there's only so many site manager jobs. There's only so many, safety manager jobs and things like that. So a lot of these guys and girls, hopefully, that are good at their job, they should have the opportunity to stay in that job. And I think the product that we have can enable that.
Yeah, it does seem like a really intuitive product. And how do people try out the Climb Auto system? Like, do they have to come down to your site down in Texas to try it out? Or I've seen it a couple places, some of the shows. How do they introduce themselves to the Climb Auto system?
A lot of our customers, we have given them units to try. We enabled some pilot programs where, we've allowed customers, we've installed a few units at their site and asked them to try them at no cost. Other customers are friends with each other, and they would invite others to come to their site and have a look and have a test drive, so to speak. We have our facility in Plano, Texas, here near Dallas, that we've had customers come and take a look at the system. But certainly, there's a lot of opportunities out there for us to install. I think we're probably in 20 states or so where we've got a lift. So yeah, almost the wind belt and a little bit out west. So
I can't believe once a technician gets onto the Climb system and uses it a couple times, doesn't fall in love with it, because it's
they don't want to go back to climbing, right? That's for sure. So they still there's some technicians who have used our lift and said, look, this is the best thing ever, and then but that tells them they don't want to go to another site, which is good for the owner. That's good for the operator, because now you're keeping the people that are in the know at your site. There's an example. We've installed these lifts and turbines that are 15, 20 years old. It's not, it's not just a product for a new tower. Yes, we're installing them in towers today that are 120 meters. But we have installed them in 80-meter towers, 65-meter towers. And think about it this way. There's, the old GE SSB pitch system. How many technicians out there are trained in that? Well, if you have those turbines, you probably have technicians who have a unique skill set. And we have a customer that retrofitted their site in order to keep those people who know the system around. And some of those technicians were in their late 40s and very directly said to us, look, if not for this system, I would have had to quit. And that's a real thing. That makes you feel good. That kind of is the personal aspect of it.
Yeah. And because wind is really going to explode over the next couple of years, we already have a huge number of wind turbines already in the States, but that's going to have to increase rapidly to meet some of our climate goals. How do people get a hold of you, Gio? I mean, do they find you on LinkedIn? Do they go to the 3S Lift website? How do they connect with you to get more information about the Climb Model system?
Yeah, they can look us up on LinkedIn for sure. Our website 3slift.com has a contact us section. They can reach us at I think even my cell phone number is still on the website. Look, we're a small growing company. We've got about 25 or 30 employees now. But yeah, they can reach out to me directly. Our team is available on LinkedIn, or a group of sales folks. So yeah, certainly a lot of different ways to get through us. We also sell directly to the OEMs. So that's something if developers or are looking at building new projects and they want to supply or interested in our lift, the OEMs may be the route to go as well. So yeah, a few different routes to contact there.
Gio, it's been great having you on the podcast. I've learned a ton here today. As 3S Lift continues to install the Climb Model system across turbines in America, I'd like to get an update from you guys to see how it's going, because it's really positive news, and your company's doing great things. And let's just stay in touch, because 3S Lift is doing neat things.
Appreciate you having me. Maybe you can come out and have a ride.
I'd love to do that. Big thanks to Gio Chardon with 3S Lift on the Climb Auto system. Really interesting system. Check it out at 3S Lift's website, or you can visit LinkedIn and connect with Gio there. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. And be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.